You have some other practicing. Check your understanding here for these numbers. How many significant figure here? 1, 2, 3, 4, because we have decimal. The number here, how many? 1, 2 only, although we have decimal, but they are in the left hand side. The number of decimal places here is 3. Okay, decimal places means how many places for decimal? 1, 2, 3, something else, not significant figure. It's something called decimal places. Okay, 3 decimal places. We have 3 places after the decimal point, it means. What if we have multiplication and division of numbers? How can we deal with a significant figure? In the calculation of multiplication and division, you need to round the answer to the same number of significant figure, but the least one, the least number. How come? Let's see this example. Perform the following operation and answer the question. Look, we have 7.55 meters times 0.34 meters. Also 2.10 meters times 0.70 meters, 2.4526 meters squared divided by 8.4 meters, and 0.365 meters squared divided by 0.0200 meter. How can we deal with these problems? Let's try the first one. How many significant figure here? 3. How many here? 2. The least one is, which is the least one? 2. So the answer must be 2 significant figure, not 3. That's it. How come? Look, the process is, the answer is 2.567 meters. So you have to write it in 2 figures only, 2 significant figures only. 2 point and make round. 5, make it instead 5 if this is less than 5. Still 5 here. But if it's more than 5, so make it 6. So change it to 6. So it's 2.6 at this moment, and we make it 2 significant figure only. The answer. To understand more, let's try the second example. 2.10 have how many significant figure? 1, 2, 3. How many here? 1, 2 only. So the answer must be 2 significant figure only. Let's try. Make the process of multiplication, and you'll find the answer is like this. Here 3 significant, but must be 2. So make round. Round the 4 into 5 because beside it 7. Now 1.5 is the answer. Let's try the third one. We have how many significant figure here? 1, 2, 3, 4, 5. We have 5 significant figure, but the second one has 2 only significant figure. So the answer must be 2 only. How come? Make the division. You will find this value. You have to make round to make them 2 only. Round this 9, still 9 because beside it 1. So it's 0.29, and at this moment it has 2 significant figure only. The last one, how many significant figure here? 1, 2, 3. Here 1, 2, 3 because we don't count the left hand side. Both have 3, so the answer must be 3 because no one of them is less than the other. Okay, so the answer must be 3, but the process gives me 4 digits here. We have to change it into 3 or round it into the form of 3 significant figure only. So round these 2 into 3 because beside it 5, so 18.3 is the correct answer for this problem. Significant figure is an operation, and as I said, you can round the values to the least significant figure of the numbers in the process. Okay, I said that. I said all of that. Also, if you are making addition or subtraction, not multiplication and division, if you are making addition and subtraction, the final result must be no more accurate than the least accurate number as well. Like this. If you have like these values, okay, we have here something plus something. How many significant figure here? 1, 2, 3, 4. And here 1, 2 only. Okay, so the answer must be 2. The result of the addition here must be 2, the least one as well. Okay, the least one. The result is 9.311 centimeter. Round it into the form of two decimal places only. Not significant figure at this moment. It's called decimal places. Decimal places. It means we need to make the least number of decimal places for the result. It means must be 2 decimal places only. 2 digits after decimal. It means. So the answer must be 3, 1 only, and we have to cancel this one or round it into 1 because beside it 1. So like this. Not significant figure ya shabab. It's decimal places. Decimal places means rounding the answer of addition and subtraction to the least number of decimal places in the process. The least number of decimal places in the process. We have here 2 decimal places. The answer must have 2 decimal places only, the least one of the process. Not significant figure here in the case of addition and subtraction. Look at this. How many decimal places here? Sorry, this is multiplication. So significant figure. How many significant figure here? 1, 2, 3, and here 2. So the answer must be 2. Which one of these? This is 2. Not this. This is 3. This is 4. This is 5. So the correct answer is this. What about if you have like this example? If you want to make difference, subtraction between D equal A minus B. A is this value and B is this value. So this minus this. How many decimals here? 1. How many decimal places here? 2. The answer must be or must have only 1 decimal place. Which one here have decimal places? 1. This is 2. This is 2. This is 3. This is 1. This is the correct answer. You understand? So counting significant figure and decimal places is easy now. You can count the significant figure in the measurement by this process, and we have many examples here. Look, according to the rules, how many significant figure here? 3, according to rule 1. What about this? How many? 1, 2, 3, 4, 5. What about this? How many? 5. 1, 2, 3, 4, 5. All of them are counted. What about this? 22. Unlimited significant figure here, as you said. What about this? 1, 2, 3, 4 only, because those are in the left hand side, not counted. What about this? We have 2 only, because those are not counted, because we have no decimal point here. SI units. What's meant by SI units? It's like System International or International System for Units. It's like French system. We studied before that. I just remind you. Okay. And we have 7 cases of quantities have SI base unit, and each one has its symbol. For length, meter. For mass, kilogram. For temperature, Kelvin, not Celsius. For time, second. For amount of substance, mole. For luminous intensity, candela. And for electric current, ampere. They are 7. Each one has its own symbol. You saw them before, I know, but just remind you that. And we have for each one some prefixes we are using in the number. For example, if you have not gram but megagram, or byte, megabyte, or whatever. Mega, what does it mean? Means 1 million or 10 power of 6. You have to remember this. Kilo, its symbol is K, and it's 10 power 3. DC, decimeter, decigram, DC something, it means 10 power of negative 1 of this. Centi means 10 power of negative 2. And milli, M small, means 10 power of negative 3. Micro, its symbol is mu, like this symbol, and it's 10 power of negative 6. Nano, N small, and it means billion times smaller, or 10 power of negative 9. Pico, B, and it's a trillion times smaller than the unit, and it's 10 power of negative 12. Some prefixes needed in our calculation, like this. This for lengths. What about for volume? We have some called liter, L capital, milliliter, M small, L capital, cubic centimeter, cm power 3, and microliter, mu, and L capital. These are symbols for volume, and each one has the rule for conversion. Quart of milk equal 1 liter. If it's 20 drops of water, it means 1 milliliter. If it's a cube of sugar, means 1 cubic centimeter. If it's a crystal of table salt, it means 1 microliter. These some examples of units of volume, units of mass, which is important. Kilogram, okay, the basic unit, which is 1 kilogram equal 10 power 3 grams, or 1000 grams. Gram, G small, 1 gram equal 10 power of negative 3 kilogram, because gram is smaller than kilogram, طبعا. Milligram, mg, which is 1000 of gram, and each gram has 1000 of milligram. And microgram, which is 10 power of 6 microgram equal 1 gram. 1 gram equal 10 power of 6 microgram, something very small. This is the units of mass. And we have other units of quantities we are using in chemistry, like energy. Units of energy is joule, J, okay. This is the name of a scientist. And other units for energy like calories, calorie, CAL, by small letter. And if it's by capital letter, calorie, it means 1000 calories from small letter, okay. You have to remember this, okay. And if you want to convert a joule into calorie, 1 joule equal 0.2390 calorie with small letter, calorie. Or the opposite, if you have 1 calorie, it means equal 4.184, or you can say 18 joule. If you want to convert calorie to joule, just make multiplication. I'll give you an example very quickly. If you have 3.4 calories and you want to make them in joules, calorie to joule, just multiply this value by 4.18 or 4.184. It gives you the value by joule. If you want to make the opposite, if you want to convert joule to calorie, okay, and you have, for example, 7.3 joule, just multiply this value by this 0.239 times 0.2390 equal value by calorie at this moment. You change the joule into calorie, so it's easy to change one unit to another. I think it's easy to change joule to kilojoule, or kilojoule to joule, because kilojoule equal 1000 joule. Kilo is easy for you. This is the end of summary of chapter 3. I hope to understand everything in this chapter. ثانك يو شباب.